Good morning, everyone. For today, allow me to present to you the last performance tasks for this quarter. And we call the performance tasks as capacitors in a circuit for performance task number 3. Now, our objective for this activity is to verify the principles that govern capacitors that are connected in either series and in parallel circuits. Now, to aid that in analyzing our circuit, we will use this FET simulator. That the link, no. So you notice the link there is attached, and we will be seeing that in a short while now. But what are the things that we will see here now in our activity? By the way, when we say principles that govern capacitors, what I mean there are the corresponding three equations that governs either the series connection and the parallel connection. So we define them in terms of their charge, in terms of their relationships of capacitances in farad, and the voltages that they have, no? And last, of course, is the charge, no, that is also in coulombs, no. So in each of these kind of connection, you will have those three governing principles, no, that is specific to either series only connected capacitances or in parallel connected capacitances. Now, for your diagram, you may show an image or a picture of one series connection that you have in your FET simulator and another one in parallel. So maybe two, and it does not have to be in every trial. Now, maybe part of the procedure will be how to use the simulator and maybe how you gather your data. Now, since we are quite aware, since we already have a discussion on series and in parallel connected capacitances, this is how the data that you are going to gather would probably look like. Now, from the first table, again, they are similar. These are similar sets. So series and parallel connections have exactly the same sets of same table. Now, what you will have here are, of course, your capacitances and the values for each of the capacitances and their corresponding voltages and charges are labeled either as C1, that's capacitance 1 in farad, and then capacitance 2, So for capacitance 1, it will have a corresponding voltage V sub 1, and it will have a corresponding charge Q sub 1. Now, the values of the capacitances, you will be the one who will determine that. So I think the only value here that you will calculate is the last column for the total capacitance C sub T. But the first three, C1, C sub 2, C sub 3, you will be the one who will determine that. Now, for each trial, I do hope that you will set a value here in a way that for C sub 1, you will have an increasing value for C sub 1. So we will see later how much is the lowest value for the capacitance and how high it can go. But again, for this listed values here, you will be the one who will determine this, taking from the simulator. Now, this last column for C sub T, you're going to calculate this depending on the principle that is governing it, either in series or in parallel. Now, the same is true for your voltages. Maybe your V sub T may come to a point that you will solve it, or you may just use the principle. But now we have a voltmeter for our V1, V2, V3. And I think we can also find V sub T, and V sub T could be determined by the voltmeter that we will show later. And sorry, V sub T should be the value of the battery, the source. Now V1 will be the setting or the value of the voltage, no, using the voltmeter when you check, no, your C sub 1 value or your C sub 2 or your C sub 3. No? Now again, it goes the same way here for the values at the bottom. No? So these are the voltmeter values. No? So VT again is for you to check, no, the voltage across the battery. Now, in terms of how much value you are going to set, no, in your battery, maybe, no, you will take, no, only one single value for the battery voltage. So based on that battery voltage, no, which your group will determine, will now be recorded. These values will simply be the detailed recordings that you get, no, but the battery voltage will be depending on what values you're going to set for your group. So two things to decide, no. Capacitances is decided by the group, no. So the values here are group, no, decision. Likewise, the battery voltage is also a group decision. Now I'm going to show later how to get your V1, V2, V3. No? Now, the last value here, no? So Q, we have no device that will determine this. No? So therefore, in determining Q, no, either in series or in parallel, we are going to use a computation portion to determine these last four columns in our table. So we are going to use the formula, no, to get Q1 or the charge in capacitor 1 to be equal to C1 V1, no? Or Q sub 2 is C2 V2, Q total is Q sub T, no, times C sub T times V sub T. So again, no, that's your task, no. And here, no, in our table, I think you can set C sub 1, C sub 2, C sub 3. But for your value of C sub T or total capacitance, I think there's a need for you to solve this, no? Because the total capacitance will not be available as well, no, in your, no, in your simulator, no. And I think, no, you have to remember there, no, the formula for C sub T, no. Okay, so I added some equations here on getting the total capacitance. So we've gone through this one when we discussed the principles of series and parallel connection. So maybe now in either series or in parallel connection, you need to calculate there the total capacitance in this column. No? Again, no, for this last three sets or four sets of columns here, you'll need the equation for Q, no? Q being C times V, no? Again, C is your capacitance value in farad, and then V is your voltage. Now, the other portions of your lab or your performance task 3 template, no, includes your discussions, observations, analysis, and conclusion. Now, you can scroll down, no, to see further, no, how your activity will be graded. So it's a total of 70 points. No? So you can examine here, no, how you can get, no, the corresponding rating for your work. No? And just take note, no, so this one will have a decreasing value. So since there are 5 columns here and the values over this one is divisible by 5. No? So you can just equally divide the value so that you'll know, no, how much is the total score that you could possibly attain. No? Okay, so that's your activity there. No? So let me change to our simulator since our table here requires us to understand, no, how these values are to be taken. So for the voltages, we will be seeing in the simulator in a short while the use of the voltmeter. No? So for the charges again, no, there's no device for that. So we will settle with our computations of our value. Okay, proceeding with our FET simulator now. We call the FET simulator again as the Circuit Construction Kit AC. So you can either use this RLC no, setting or the lab no, setting. But maybe now for this AC voltage, there are no capacitors here. So we may as well click this one. No? Now here's the interface no, of the device. And again, no, among the components that we need, no, maybe we will need a wiring. So that's how we drag it. No? So we click it from this end, no, going there. We may need probably one battery. And you can rotate a device or anything there, no, any connection or gadget by touching it at the tip, no, at one end, and maybe now you can rotate, no. Now, if you drag it on its body, you will never be able to rotate it, no. Now, whenever we click also the ends, no, you'll see a scissor, and the purpose of that is whenever we connect already components and we want to detach them. So once you decide to remove it, no, you can click no the node or the connection and then click the yellow scissor to be able to remove or separate them again. No? Now, any components that you don't need, you can bring it back no, to this menu here. No? So let's select one wire. And of course, we'll need to link it to our battery. No? Now, you can add actually no, as many batteries as you would want. No? And the way you can attach them in series is, of course, in this way. But you'll realize that the range of values of one battery no, can go to an extremely high value. So even though we will just simply settle with one, no, with one battery, I think we could have as many voltages as we could need there. No? Now, let's check that in a while. No? Now, the next thing that we need are capacitors. So our first setup will allow us to connect no, capacitors in series. So if you connect them in series, it may probably appear this way. No? Then let's just connect the last one no, in this way. Maybe let's just extend that no, to provide it with some space. And maybe now we can connect this last device. Okay, so I think now we'll extend it just a little bit, no, so we can be provided with some space here, no. Maybe let's just have it something like this, so that we will have some sort of a space. So let me attach this. No? So now we are connecting 3 of the capacitors. Now we will need probably a switch here now because eventually when we connect our circuit, we don't have to switch it on readily now because our capacitors, when they are charged now, they can you will not see any movement of charges anymore once it's fully charged. No? So we will need a switch there, no? So to activate our circuit. No? So maybe now with the help of some wirings, 3 capacitances, no? A battery and a switch, we are now able to make our wire. No? Now maybe we can call this a C sub 1, no? And if we click C sub 1 again, we are able to change its value no, to as low as 0.05 farad to as high as 0.20 farad. So in reality, we could never set, I think, no, 1 farad value because that's relatively no a large value. So you'll notice that the distance between the plates changes no whenever we adjust the number of farad. No. So again, for your case, you can set C sub 1, C sub 2, C sub 3 no, with 3 different values. No? So your smallest value for the capacitance is this much up to a maximum of 0.2. No? So you can also use this no, to reduce the value. So you can have that one. No? Or you can simply slide this one. No? Now again, for your setup, you have to have no, 3 of this. So I do hope no you get the value. So again, to change the value, you can simply click the capacitance or capacitor and change its value. No? Now, the default setting of the capacitor is 0.10. No? So if you get a component here and just drag it all the way, you'll be given outrightly a 0.10 farad of capacitance. No? But again, for trials 1, 2, and 3, you must have an increasing value, however, of C1, C2, and C sub 3. No? So that's again, if you go back to the table. Now, for us to measure the voltage, we will need a voltmeter here. No? So our voltmeter will need you will have to attach this probe or this electrodes. So maybe to get the voltage of C sub 1, you have to place it somewhere here. No? Now, you will not see any voltage because we have not energized our circuit. So if we will now energize our circuit, so we'll see that we can now get a voltage across our voltmeter. So whenever the electrodes or the probes are reversed in direction, you will end up with a negative answer here. Okay. So this will serve as your C sub 1, V sub 1, I mean, voltage 1. So this is your V sub 2. And if you want to get your V sub 3, you could now also transfer the probe here and get, so you can just position the voltmeter. So that's what we call the voltmeter. So these are the 3 voltages. Now, if you want to get the total voltage, you can probably position it across our battery. So either over here. So that will now serve as your total voltage. As I've said, you can vary the value of the voltage by placing it or by increasing it over here. So you can go as high as 120. So maybe as low as this one. But you don't have to use a very large value because for your experiment, you have to set a single value all throughout. So for series connection, you just use one value, maybe 12 volts if you want. So you can increase this up to a value of 12. And maybe all throughout your activity, you can use 12 volts. Or maybe a little lesser if you want for your group. So maybe 9, 10. So you have to decide for your group. Now again, the C values or the capacitance values are also determined by changing this. And however, the only one that you will solve also is your charge Q. So Q will now use your expression C times B value. Now we will go into our parallel connection. For our parallel connected capacitances or capacitors, we will just rotate our capacitances. Again, if you remember, we can move or rotate the device whenever we hold it at the tip. So you can detach your series connected capacitances and then using that the scissor. So you can collect, you can click any connection or node, and then you can cut it with clicking this yellow part. So again, to do that, click this end and then detach. And then therefore you can now rotate. Now let me cut this portion here, so we'll be able to attach this. So we'll need maybe now more wirings on this end. So that's one. So let's disconnect our wire first, our switch. And you'll see that our capacitor here they are already fully charged. No, they are already fully charged. So one way to probably disconnect it or to discharge it is to have this short circuited. No? So you can remove the charges there, no? By putting a short circuit wiring. So now they are empty. No? And again, no, we can disconnect this end again to be able to remove this short circuit wiring that we just used. No? So anyway, we go back now and reconnect it. So let's just reconnect this one. No? So now here is our circuit again. So these are now connected in parallel. And again, now the things that you are to remember, you can change the value of the capacitance by sliding this one. No? So from trials 1 up to 3, you have to you have to have an increasing value of C sub 1, C sub 2, C sub 3. Now, if you decide to use the values that you use for series connection, you may do so. No? So for the different trials, there's for C1, C2, and C3, you want to use the same value, then you may. No? However, for the total capacitance, again, those that column requires you to solve the total capacitance. Now, for the value of the voltage, you can now place your terminals here of your voltmeter once you turn on your circuit. So once the circuit is closed, then you'll see that you can now get a reading for the voltmeter. So this is how we probably could get the value of the voltmeter value. So this is our V sub 1 when we position the voltmeter here. Now, whenever the sign of the voltage is negative, it simply shows that you have to change the location of the probe. So just disconnect the probe and transfer this one and make some corrections so that you will not get any negative value. Now for our C sub 1 of Q1, Q2, and Q3, you have to use a formula. So this is how we use our circuit using our FET simulator, both for series and for parallel connection. Just a little reinforcement. So what are the things again that you are to use here? So for C sub 1, C sub 2, C sub 3, C total, C total will need a formula that we added below. So either you use series or parallel connection, you can get the C total there. Just use the correct principle. And then for the values here, the suggested values are for C sub 1, C2, C3, they must be increasing from trial 1 to 3. And the voltages are to be determined using your voltmeter. Now, this is the column where you will solve. And again, for Q, you will need the equation C times V to get each of these needed values. So this one, since there are values that you calculate here, must be shown in our computation portion on number 6. So for total capacitance, for Q values, you must be writing quite a number of things here that you solved and you included in your table. So again, for the portion for computation. Now, don't forget again to complete the discussion, observation, analysis, and conclusion, because they have quite a significant weight on your activity. So there's 40 points and 10 points for both of them. So that's basically 30 points already. 50 points. So don't miss that part. So that's quite crucial to your score. Okay, so for today, I think that's all.